Hello guys, welcome back to my YouTube channel. So today we are going to discuss another most asked Google interview question. So the question is largest rectangle in histogram. Given an array of integers heights representing the histogram's bar height where the width of each bar is 1, return the area of the largest rectangle in the histogram. So if this is the input like 2, 1, 5, 6, 2, 3, this is the input given, then the largest area of the rectangle will be 10. So we are returning 10 here. In the second example, if we are given 2 and 4, then the largest area is 4. So we are returning 4. Height's length is given as 10 to the power 5 and each height value can be up to 10 to the power 4. So as n is 10 to the power 5, so like the maximum acceptable solution is up to n log n or n. Like both would be acceptable. So let's understand how we'll solve this problem. So let's take the example which is given to us in the question only, and let me take out pen as well. So yeah, this is the example which is given to us in the question, and here at 0th index 2, 1, 5, 6, 2, 3, these values are given and these are indexes. We can say that these are indexes. Okay, so so first basically we are plotting this histogram. So this is of height 2, 1, 5, 6, 2, 3. So in order to calculate the maximum area of rectangle, we will consider each and every this bar one by one. So if we consider the bar 0, then we want to find out like considering like it has a height of 2. So with this bar, how much maximum rectangle can be formed? So we can see that like we cannot go to the right side and we cannot go to the left side also. So only this area can be formed. So here maximum area is 2. Then we'll move on to the next bar. So here bar height is 1, but we can move on to the left also, and we can move up to right also, and we can move up to 5. And here we can move up to 0. So total it will be from 0 to 5, so that is 6, and into height 6 into 1 6. So our maximum area till now is 6. Then we'll move to this like its height is 5. So from 5 we can go up to from left we cannot go anywhere, right we can go to just one point, and this will be 5 into 2, that is 10. So our now updated answer is 10. Then we'll consider this 6 height. 6 height will be from left we can go nowhere, from right also we can go nowhere. So our height like our max in this case area is 6 only. So it is not greater than our answer, so we will not update our answer. In the next case, like this case, we can go from here to this, and from 4 to 2 and then 4 to 5. So our answer can be 2, 3, 4, 5. So that is 4 places into 2. So that will be 8. So that also will not consider because our already answer is 10. Then we'll consider this 3 height. So we cannot go to left, we cannot go to right. So 3 into 1, that is 3. So our final answer is 10 in this case. So this algorithm will take O(n) square time, because for each of this bar we are calculating where it can go to left and where it can go to right, but using stack we can bring it down to O(n). So how we are going to implement it using stack? So using stack we can implement it in O(n). So first what we will do is like we will take one stack, and as it is empty initially, so we will insert the first index, 0th index, and we will in this stack we will maintain the values in the increasing order. So when the first element will come, so we will check its value is less than uh, the already top element. So at 0th index like 2 is present, so and at first index 1 is present, so 1 is less than 2, so we will pop out this 0th. Like here we are storing indexes, but we are comparing the values. So like we'll pop out this 0th index, and we'll see like if after popping out this 0, this stack will become empty. So we will just consider the value which is the incoming I. So like we'll consider 1 minus 0 here into 2, because 2 is the height. So 1 minus 0 into 2, our initial answer will be 2 here. So then 1 will come, and like 0 is popped out, so we will insert 1. Then 2 will come, so 2's value is 5, which is greater than 1, so 2 will also get inserted. Then 3 will come, its value is greater than 5, so 3 will also get inserted. Then 4 will come, 4 value is 2, so 2 is less than 6. So here like we will have to pop out this 3. So in order to pop out this 3, like we will check what is the index, like we are checking for this 3, what is the right and what is the left index. So here right is 4, like we cannot go up to 4, but we can go up to before 4. So like right is 4 and left is 2. We can see after popping out, like we check the top element, so left is 2. So 4 minus 2, that is 2, and we will also subtract 1 because we cannot go up to these two elements. So 4 minus 2 is 2 and 2 minus 1 is 1. So 1 into 3, that is 3. So now our answer becomes 3 because 3 is greater than 2. Sorry, at 3 the value is 6, so our answer becomes 6 into 1, that is 6. Now we'll check, like 3 has been popped out. Now we'll check the value at index 2, so its value is 5 and 5 is like greater than 2, so we'll pop out 2 also. So for 2 like the value will be 4 minus 1, that is 3, and we'll also subtract 1, so that is 2, and 2 into what is the value at 2, that is 5, so 5 into 2, that is 10. So we'll update here our answer, that is 10. Then like we will check for first index value is 1, and currently we are considering the value 2, so 2 is greater than 1, so we will insert 4 here, like the index we are inserting. Then we will check like what is the value 5 at 5, so it is 3, so it is also greater, so we will insert 5. So now we have traversed all the elements. So now one by one we will empty this stack, and our right value would be the total number of elements in the stack, so that would be 6. So our right element here, like as we are popping out all the elements from the stack, so our right would be 6 here, and if we pop out 5, then left is 4, so 6 minus 4, that is 2, and 2 minus 1 is 1, so 1 into value at 5, that is 3, so 3 is not greater than 10, so we will not update. Then we are left with 4 and 1, so then we will check for 4. If we pop out 4, then we are left with 6 minus 1, that is 5 minus 1, that is 4. 4 into value at 4, that is 4 to the 8. 8 is also not greater than 10, so we will not update. Then we will just left with 1. So if we pop out 1, then we are just left with empty stack, so we will consider it as 0. So 6 minus 0 is 6, and value at 1 is 1, so 6 into 1 is 6, so 6 is less than 10, so we will not update our answer, and our finally our stack becomes empty. So in this way we will update our answer, and finally we will convert our answer as 10, and our time complexity would be O of n. So let's go to the code and understand it. So initially we will define one stack, and then we will define int n as height size, and then we will define our answer also. This is one more integer which we have defined. Then what we will do is like we will iterate through each and every element. Here we are iterating, and then finally we will empty our stack. Here I can write we will empty our stack, and here we will iterate through each element. So initially we'll check if stack is empty, then we'll push I. Like here initially as stack was empty, so we've just pushed this 0. Then what we'll do, if stack is not empty, means it will come in else condition. So we'll check if stack is not, while stack is not empty and height of I is less than height of st dot top. So if it is less than top, then what we will do is like we will take out the top element and we will pop it out, and then we'll update our answer. So if here also we'll check if stack is empty, then we will multiply by I. If stack is not empty, then we'll multiply by I minus 1 minus st dot top. So in this way we'll update our answer max, and finally we'll push this I index also, And similarly we'll iterate through each and every element, and we will calculate our stack value and our answer value. And then finally, like when we have iterated through each and every element, then we will check the value of our stack. So we will one by one pop out the top element, and we will, like here also we'll check if stack is empty, then like we'll just multiply the height by n, otherwise we'll multiply the height by n minus 1 minus st dot top. So yeah, in this way we'll update our answer and return our answer. So in this way, like we will be able to calculate the maximum area of the rectangle. Let's try to run this code and see whether it works fine or not. So it is working fine, and then we will submit it as well. And yeah, it has got accepted. So the time complexity is of n, and yeah, it's working fine. I hope you have understood the explanation to this solution. So do like this video and subscribe to my channel for more such important data structure and algorithm questions. Thanks and have a nice day.